I'm not going to talk again about accuracy, precision, and recall. There are examples here. But F1 score, which was not shown in this screen, pretty much combines precision and recall into a single number. And it, as an example, if precision is 70% and recall is 70%, F1 score is a formula that gives you a balance of both. I didn't include the formula here, but it's very similar to accuracy in the sense that it's a balance between precision and recall. But again, you're going to use F1 score together with the other ones to gauge whether you care or not about it being useful for both true negatives and false positives. In my experience, at least, the most useful metrics are precision and recall, because usually the false positive or the false negative will be much more, one of them will be much more important to minimize than the other. And finally, there's this curve that you will see a lot if you are working on machine learning models. They call it the ROC AUC curve. ROC means receiving operator characteristic. It really doesn't matter that it's named that way. What's important is that in this curve, you plot the false positive rate of a model. So if a model has 70% false positive rate and 60% true positive rate, then a point on this chart just shows where the model is in terms of the balance between these two. A model that is completely random would have a curve that looks like this, just a straight diagonal line. And the usefulness of this chart is that the bigger the area around here, then the better the model is just in general at being able to predict both true positives and true negatives. And yeah, it's very likely that you'll be met with a curve like this when doing model evaluations. And AUC just means area under the curve, area under the curve. The bigger the area under the curve, so the bigger the curve is, a perfect curve would look like this, then the better your model is in general. Here's an example of an even better graph of ROC AUC curve.